Hi everyone. We are about to start the session about Rails autoloading, and we will discuss the good and also not that good things of that mechanism. There are 3 seats. Marcus will take one of the seats. I'll sit on the second one, and the one in the middle is for anyone. So don't hesitate and take that seat if you want to participate in the discussion. Also, feel free to ask questions while we discuss. To make something more precise or to add your question, there's also under that URL a list of questions that I'll be looking at from time to time. So feel free to add your question there as well. And to begin with, let's discuss what problems was autoload designed to. What problems was meant to...
I wasn't part of the design process. I just had to experience autoloads from the other side. But I assume they were decide to make the 5 minutes to a block example more beautiful.
So you don't litter your code with require?
Yes, exactly. So you have to explain one concept. You have to explain one concept less when you are trying to market the tool to developers. So that's basically the main design constraint, which I assume had happened. I wasn't part of the Rails community or even Ruby community at the time Rails was conceived. I only see the autoloads, the effect autoloads have on everybody right now, and I assume that this trade-off has gone wrong badly.
I think the other thing was that autoload is somehow connected to the class reloading that you could use in development.
Okay, the class reloading on development is quite a futile attempt because there is no way to clean up any kind of debris which has leaked into adjacent classes. So if you think about it, we have a strict evaluating language. When you write a statement in Ruby, you assign a local variable. The local variable value at this point of evaluation is fully materialized on the heap, on the stack, whatever, depends on the implementation. So it's a strict evaluating language, which allows you to have a language construct which lazily initializes globals. But this initialization is then allowed to have side effects. There's no way to guarantee that this initialization or worse reinitialization is not side effectful. And I've seen lots of Rails deployments where these servers have gone into a different global constant lookup state, even for very important classes. So I've seen basically servers gone into resolving constant A or constant B for the same fully qualified lookup, depending on the way on the sequence of autoloads being triggered. And there is nothing in the language which can prevent this kind of problem. And overall, the high cost associated with maintaining this feature, especially for tooling, is preventing lots of good tools to work these days. So,
so until we dive into the bad things, what other good points of autoloading? Can you help us?
So probably the app can serve the first request faster. I do not think it's a good idea to optimize for the first request, but it's something you could list on the positive side.
Okay, so issues with autoloading.
So we have the big problem that basically the issue list is really long. So the problem is here is so you delay initialization. So a Ruby application has no compile time. So we substitute the inability to expand certain structures for runtime metaprogramming. And each application needs at some point to finish the runtime metaprogramming and then reach a state from which where each request, assuming it's idempotent, can be served idempotently with some kind of guarantee. And if we keep on delaying applying metaprogramming against our environment, we just keep the point of inflection where we are now fully expanded. From now on, the application is supposed to be deterministically till the infinite future, which basically means if you were an honest tester, you need to set up your tests in a way that they observe every different possible initialization state of the mentioned metaprogramming primitives. And nobody can obviously do this. It would even be more computational intensive than mutation testing. So unless you are able to force your application into a fully metaprogramming and global extended state, you can never, with honesty, run a test against this and claim it's production ready because my tests are passing.
And there are multiple entry points.
There are multiple entry points. So there is third-party libraries really like to implement their own autoloading for certain subsets. There requires firing 30 minutes into a running Rails application under high load, which nukes the constant scope. And you can just all the caches, the constant lookup caches, get nuked already for rarely used features, affecting all the threads which are now waiting for the global interpreter to all the threads which may resolve a constant after such a nuke happened. And I've seen.
Can I interrupt you?
Sure, it's the idea.
Because technically speaking, on production, Rails uses eager loading mechanism.
Technically, yes.
Unless you configure it differently and you have additional directories which you did not configure to use eager loading.
Question.
So technically, by design, it should be deterministic on production. So the issues that you mentioned, do you observe them in production or in development?
I observe them in both environments because all third-party libraries also really happily delay a require which affects the global constant scope to infinity till the first time XML is parsed, which happens only when the backend administrator uploads a new whatever dump. So it's like for me, autoload's just a mechanism which Rails is in the front is just a tip of the iceberg. It's the entire ecosystem which tries to sacrifice a constant environment for time to first request served. So for me, it doesn't end with Rails autoloads, and even Rails autoloads as they exist right now the eager loading depends on artifacts which are typically not controlled, like file ordering in your file system. So even then, you will have the situation that if you look very carefully, that the global state is slightly different, which at some point will result in inconsistency. And these inconsistencies are things you cannot account for on testing, especially on testing when we are eager logging typically. So I in my projects, I really fight hard to make sure everything is expanded deterministically, and it's significantly more time extensive to fight against the eager loading mechanism to expand deterministically than to maintain a global require list.
I think it does. I might be wrong, but I think it does not depend on the file system, but always uses alphabetic sorting. But this is something that you never consciously think about when you just develop. You add a new file and you don't think that, oh, now this file is going to be loaded earlier because I used
But
this
there's
letter
also
instead of
backtracking
that.
cost involved. So the Rails boot time with eager loading enabled needs to backtrack on each unexpanded constant. And
Yes.
possibly has to recursively backtrack through n levels. So
So it's mixed kind of.
yeah, it's a mixed kind of. But even if you let's say the file system sorting issue is the last time I've dealt with it is years ago. So I do not I patch out auto loading immediately and I remove all the call sets in active record. So I have a giant patch which kills all this entire feature set, and I have a giant require list. But the point here is that the point here is that you are never that your environment under test is never equal to production unless you are running the same thing in production also. And under tests, it doesn't exist because my app would boot too long to get me my first green dot.
Completely
But
agree.
the first green dot is the worst possible metric to optimize for because I want all dots. And when you constantly hit new expansion sites which nuked all the caches, you're basically in sum paying much more processing time to do something than to be honest. And so time to first byte is the worst possible metric. Time to first meaningful byte is the interesting metric. And on a HTTP request, the first meaningful byte is the last byte of the response because then you are done. Because then you could potentially start rendering. Okay, browsers try to be a little bit more eager, but if you were going for a strict interpretation. And the same is for when you run a subset of tests. Time to first meaningful test result is the last test result because up till the last test result, it could still fail and give you a meaningful feedback. So the first green dot is the worst possible metric to optimize for. And in the entire ecosystem, we try to optimize for the first green dot at significant expense of tooling discoverability and overall efficiency because we constantly nuke all the caches.
There's one thing to add. You mentioned that you don't take some decisions consciously, and you have to be conscious how to name files and have them on a disk in a particular way for the autoload to work.
Yes, if you want to have 100% control. So just to say my experience with the tooling, since like the beginning of my career, since 10 years in doing Ruby, I've been only working on very big Rails applications, and in every one of them, I I don't think I had ever a problem on a production machine, but in development mode, it's never ever deterministic in any of those apps. And I remember the rules that uh, I supposedly need to follow for everything to work correctly, and yet still things break randomly, indeterministically, and you press refresh, it does not work. You click
But
refresh,
that's
and it
reloading.
works.
Reloading is a different kind of issue because basically there is no way you can guarantee that some kind of global effect what some of your earlier state had. So let's go with a very, very pointy example. So let's assume it would be justified to write to a global variable, and you then remove the global variable and reload your class, but the global variable is still in effect. So there's no way the Ruby interpreter can or any kind of class reloading can remove any kind of global effect you ever had. And there are lots of global variables in disguise. We have thread abort an exception, which is really a big issue when you deal with any kind of third-party library which tries to make a global decision for everybody. There is safe. There are the string separator settings. And these are all global. There are settings on regex. I think they're a little bit cleaned up, but these kinds of effects cannot be undone if being called from such a class which is supposedly being reloaded. And there is more debris in the, for example, you're reloading a model, and the model had set up an association, and the association was set to be to have a counterpart in another model. How the other model, which you never touched literally, gets rid of this association? In truth, it does not. So each time you're pressing reload, you're creating an in-memory environment which is further from the truth of production.
So we are playing with fire.
Yes, we are basically playing with an inferior mechanism. And one idea to solve this would be to just throw away the AVM and boot a new one. And this is a significantly more stable approach. But even then, you have the problem that you only observe the side effects of all the constants which have been loaded right now, which may not be the side effects you will observe in production. And in production, it may be possible to configure Rails itself, but as long as the entire ecosystem relies on autoloads, more uncontrolled autoloads than Rails even provides, there is no way to ever be safe. So the first thing I personally do is I patch out kernel autoload, I patch out kernel require after this so-called inflection point when I'm ready to serve request, because from this point on, I need to be sure that an idempotent request is served against the same semantics in my global state.
Okay, so is there a way to control what's being autoloaded? How to have more
only
the patching of those.
The current this is only the current version, current way I'm aware of. You can find this problem. The problem is that there's a huge resistance of in the entire ecosystem. So there's always more crazy ways to inject new code into the environment. So recently I saw a library which abuses the instruction sequence representation to just bypass all the let's kill eval attempts. So there is always it's an ecosystem problem that the developers in the Ruby ecosystem do not understand, that they need to provide APIs which create an idempotent global scope of leaked semantics. And unless they do this, they will find will find a futile attempt. And yes, we have a more pretty autoloader now in Rails, but as long Rails preaches autoloading, and as long Rails preaches, yes, you can test at a subset of expanded globals, and this test is relevant for your production use, this problem will not go away.
So, to recap, what do you do on a new Rails application to disable all the mechanisms?
I'm very fortunate I do not have to deal with new Rails applications. I deal with legacy Rails applications. And it spends significant amounts of time to first force all autoloads to expand. Sometimes a good strategy is to have an endpoint, which is admin only, which lists all constants, and you can diff it against your local boot. So you have a freshly boot Amazon EC2 instance, and it's running for 2 weeks. You can hopefully be sure everything was expanded, and you just dump the constants and compare it against a local boot, which is also running production environment, and you think, oh, this one we need to forcefully expand, and that one we need to force. We will be shocked what kinds of third and transitive dependencies are really slow in getting you the full
How
expanded.
big is that list usually?
It really depends. So I touch 3 different legacy applications per year, so my sample size is not really good.
Yeah,
So
but is it like thousands?
it depends on it scales up with the number of transitive dependencies. So everybody does this. Everybody thinks I'm special. I will not fail. So same with for example even Ruby stdlib. So you have like some random library may weigh 15 minutes in production just require RE XML, and you see the spike because all requests served afterwards have a new constant cache, and you can just see the spike in response time. And when you're on tight time budget, it costs you to counteract this one. So this entire concept of lazily initializing global state, because we are not in a referential transparent language without a type system, is just futile.
I personally don't have a good solution. Like the only thing that I know how to do well is how to do it in jams. You can explicitly require everything from top to bottom, not use any autoloading, and it always works. And yeah, if you forget to require something, you discover it during the first test run.
Yes. It's basically,
And
this is the only strategy that I would consider valid on Ruby where we don't have any other means. So just eats the fact you have to maintain this required list. Yes, it's ugly, but all alternatives have a significantly higher long-term cost.
Yeah. And so some people think or claim that it does not scale. In my opinion, it scales really well, because if you forget to add it, your test just fails and you immediately know that you need to fix something, and it's fixed and it works from now on ever after. And yeah, and if you remove file, then the tests will fail again, saying you can't load an existing file, and again the feedback loop is 1 second.
Yes, and you don't have to fight any kind of, did I expand all the autoloads, did I compare against 15 weeks into production machine. So all these problems just disappear, assuming you can make them disappear, and it's lots of work on Rails to make them disappear. So
but you went even further, trying to make
yes, because I
a
cannot.
Rails environment.
Yes, so there is you can just create some monkey patches which just kill the code which would expand an autoload and turn it into a race. So on this basically allows you to expand all the autoloads, run this monkey patch, and then in production, when there is a delayed autoload, which basically proves that you missed to have this constant and its side effects in your tests, then you are sure, but it's too much work. So as a community, I would really ask everybody: is it worth that we do not that we carry all this cost, all this uncertainty forward or not? And so this is an interesting question. And the longer I talk to people, maybe they do not like to oppose me in person, but so far I never had someone standing up with the argument for long enough. Obviously, it starts with, yes, it's easy to explain. Okay, yes, it's fine to explain it. But if you are 2 to 3 weeks into your job after being exposed to Rails, you find the first problem, then you find the second problem, and then the total cost of ownership of this feature is already higher than writing a stupid require.
Ruby has a autoload mechanism outside of Rails. There is the idea to use that kernel autoload for Rails autoloading.
Yes.
And there was the discussion on Ruby Tracker, on Ruby issue tracker, where the feature was, I believe, scheduled to be removed, but recently Matt said that it will stay for Ruby 3.0.
That's bad. But there is another problem with dynamic languages, because in a dynamic language, you are biased to only add to the language because the cost of removal is so high. So think about it. If you have a language which has a type checker, and you remove a really bad API, the compiler will just list you all the call sites, and adopting this breaking change is an easy task. Whereas on a dynamic language, you are significantly as a maintainer, because you do not, as a maintainer, I'm a maintainer for stuff other people that do not pay me use also. You want to make it as smooth as possible. And I second every maintainer of a dynamic language who just decides we do not go through this shit show of removing something because people do not have the coverage and they will have problems in production and I will get blamed for this. I totally second that feeling. So you should be really defensive to add such features, or even possibly consider to not run a dynamic language environment because it has all these hidden carry forward costs, where you are opting into a language which cannot be cleaned up as its core because the maintainer has to refuse such changes because they will be implicitly biased to only add to the language because removal or even change is too costly.
There was a question about dry system. Is anyone familiar with that solution? Anyone here? There's one person. Come here.
Take your time.
So dry system was this dependency injection mechanism, or
I think so.
does it is it an outward mechanism, or is it?
The question is how that dry system can be used. Could it be an alternative for Rails autoload?
So hello.
And if so, in which way?
It's a good question. Not sure that afterload and dry system is absolutely equal stuff. Because the general idea of dry system, you have invention of control container and some dependencies in your code like services, models, repositories, and etc., etc. And the general idea of dry system is to put all the stuff into container and also say for specific dependencies that what you need to do on start your application, on first call, and on stop your application. It's you can use afterload for easily registration all your dependencies into container, but in general it's a little bit different because you don't need to load the stuff. You need to load the stuff and put into container. And in this case, you can use it by hand, just require all the stuff and register it into a container. But also you can use afterload and dry system, if you remember right, support afterloading your dependencies from specific folder and put all these dependencies into a container without any work from developer side. I mean, just require all the stuff and that's all.
Okay.
The problem I see is that this is a library level solution for a language level problem, and
Yes,
it requires on all humans who contribute to a specific deployment, which are not on your team because of your dependencies, to follow the same approach, and this will not happen unless the language forces it.
Also, one more problem here. For using dry system, you need to use dependency injection because if you will start calling all the stuff from code directly, it will be terrible and looks ugly. And that's why you need to change your mind. And also, dry system was inspired by Clojure library. If I remember right, it's called components or something like this. Maybe someone know Clojure and this library. And yes, you have these problems which you described now.
Yes. So the interesting problem here is I don't see a good solution than the only one to just urge everybody to use the require list and outlaw any kind of autoloading. Just like the JavaScript community accepts we do never use a double equals, we should never use any kind of autoloading mechanism. That's just something the community has to agree on. There is no way to, because autoload is not going away, and I understand why, because they want people to upgrade, and they do not want people to have silent breakage, which will only be discovered in production, which is the ultimative check. And so there's the only way to inform people about the dangers and the overall cost, and to slowly phase it out, because it's in JavaScript, if you upload any kind of JavaScript dependency, people will rightfully say, hey, here's the double equals, and they will just avoid it like, okay, conscious people will just avoid it like the pest. And this is the same opinion I hope that people can learn on any kind of lazy initialization of global semantics in a non-referential transparent language.
Yeah, and also I want to say that dry system in general allow you to solve little bit different problems. For example, you have recursive dependency. This means when you have dependency A and dependency B, and dependency A requires dependency B, which requires dependency A. With default Rails afterloading, you can detect it on start your application.
Yes.
You can detect it only when someone send a request and everything will broke. With dry system, you can detect the stuff on starting your application, on booting your container. And also one more problem here, we discussed it a few minutes ago. Open project, it's a discourse project, configuration installation folders, and you will see a file naming like 001 something, 002 something, and etc. etc. And folks from discourse try to create a specific order for loading all stuff, because, for example, before load sidekick, you need to load Redis.
Yeah, and this is basically very, very inefficient encoding of a require list.
Yes, and with dry system, you can say, okay, for load sidekick, please before register Redis, load it, and after that use it in sidekick.
It's also fine that if a dry system allows you to basically manage the require to be sequentially executed, it's totally fine. I don't say you have to maintain the require list sequentially, literally. You can still, but the problem is here, it needs to be a require list, and after the require list is done, and then requires are forbidden, else you buy into all the problems we have been discussing here all the time.
Yep. And that's why I can say that after loading and dry system, it's dry system don't fix problems of after loading, but dry system is abstraction on top of after loading, which help you with your dependency in your project.
Okay. If you're an author of a library, you still have to consider the effects of the autoloaders.
Depends. So the problem here is that as an author of the library, you are free to register anything to the global consent scope. And the interesting thing is, from the moment on you patch something into a front-end library, this is basically the point where you have to think really hard on what your extension point will be. And I typically shy away and typically ask people to integrate with me rather than I provide any kind of mechanism, because it must obviously go wrong. What typically makes sense is that you do not ship the integration by default, but as a separate require entry points. So the users which assemble from your gem and want to use integration can require it at their preferred time, which then puts more power in the hands of the users to require integration, which does these kinds of cross namespace registration if required.
If I remember right, dry system, I never use it, but if I remember right, dry system allow you load gems or libraries in specific order and in specific way. For example, you can load some library, create a container in your library, and load it into specific namespace in your application. And sometimes it's helpful. I know that Piotr Solnitsa made it for some specific stuff around Rome, if I remember right, or something like this, and it works for him, but I never use it. And if you're interested with it, you can check documentation for dry system. If I remember right, it's last topic in this documentation or something like this.
Okay.
I've got a question to Anton, because you're also involved in Hanami, right?
Yeah.
Is there a similar concept to autoloading in Hanami?
If it's a good question, I don't remember really, but if I remember right, yes, you have application in configuration folder, and you boot your application from the start. Hanami application, it's a big container in under the hood. Hanami application, it's a big container, and each application, logger, model, actions, and etc. It's just a part of containers. In this way, we are allowed to use a modular system. I mean, we can drop, for example, one application from loading, just stop booting part of container dependency, but it's private container. And in this case, we allow to use after loading for library folder. Like you put your entity or any stuff into library folder, and you can load it without specific requires.
Question: does it allow to partially initialize the app? Does it allow to partially initialize the application?
I don't know, I think.
So if it were to allow to partially initialize the application, it will be used and abused. So I would argue that if you create any kind of abstraction over maintaining a sequential require list, that you only provide one entry point, and this always results in this, there's no configuration. It's just like this entry point always results in the same global state.
Yeah.
And it's either all or nothing. And then you can, then you would qualify for my replacement use. Do not use autoloading with dynamic expansion, but just call this API and you're done.
Yes.
Okay.
Exactly. But again, in Hanami, we use container under the hood for loading our dependency, like actions, application, etc., etc. But you always can use one more container. For example, Hanami really great works with dry system without any problems. You can easily add it, integrate it. I know that in Rails world, dry system has some troubles because after loading is really strange, and you can put something into library folder without any problems. You need to patch Rails application for load some specific stuff, and it can be hard to load the stuff into container in dry system. In Hanami, we don't have this problem, and that's why we can use one private container for our framework and one public container for your domain logic and business logic, repositories, and etc., etc.
One question for the audience. On what's the ratio between models and controllers and required dependency statements you have in your Rails applications? So is it 1, is it 2, is it 3? So let's try it with hand signs. So everybody knows what I mean with this required dependency. It's a Rails-specific mechanism to make sure that a specific model is loaded before another model or containers. Okay, so what's the ratio between the number of files you have in your model and controllers, which are subject to autoloading, and the required dependency statements? Is it 1? Is it 2? Is it 3? And no hands are raised, so is it 0?
Have no idea.
Yeah, so I've seen that I've seen some teams trying to fuzz this to make sure that that all the required dependency statements, which are required to break loops or to create determinism for their tests, to be fully stated, so that the dependency or load order dependency resolution mechanism never kicks in, and everything is required via these required dependency statements. And if you do this full expansion, it turns out that it's basically just the required list I'm arguing about. And this is a really interesting situation. So if you were really to explicitly list with required dependency all the things you need for a specific model or controller to load, so all the constants are initialized, you implicitly create this required list you should have, and you can potentially better manage with system select REST system. And this is an interesting thought of mine who just came when you mentioned that there is a way to externally specify the dependencies.
So one more interesting idea around the stuff to loading dependency, like dry system. It's just my idea. I create issue in dry system, and maybe in future it will be implemented. But instead of checking constants from different classes or modules, you can create a graph of all your dependency in application. And it's mean you can detect that, for example, account domain call something from order domains. If you are talking about e-commerce system, and if you have this graph, you can say, okay, I want to inject into my actions only some service objects, operations, call it like functional object. I want to inject only functional object only to actions, and that's all. And if someone try to inject, for example, a repository into my action, it will break anything on the start application. And in this case, we will create one more abstraction, but it will be like a Rubocop, but for dependencies.
More or less, it's a dynamic type check.
Yes.
Okay. So.
And also, it will be helpful for understand, for example, if you have a large application with a lot of dependency, you can usually sometimes I have a question for everyone who use specific graph library for detect dependencies across tables in your database. Like, I don't remember the name. When you see...
For engineer?
Yeah, something like this. When you see that account table can be joined with some other tables.
Does this library evaluate the association?
Yes.
Okay.
Yes.
Then
Yes.
it's
This one.
probably for engineer.
Yes. Yes.
Dependencies of the database tables.
Yes. Yes. It's super helpful to understand associations across tables, but we can provide a similar way to see a list of dependencies in your project, and it will be easily for onboarding a new developers into a large project.
Okay. The interesting question I would like to ask the audience. So, how many of you would think that if you were, so from the moment on your socket is opened and open to the world and ready to accept requests, how many of you could right now patch out the kernel autoload and not get any production failure? Just raise a hand.
I don't use Rails, that's why I can.
No, it's not. Rails doesn't use the kernel autoload. I'm talking specifically about third-party dependencies with lazy initialization.
Oh, okay.
And I would, if you want to, please try this experiment, and we'll be really surprised what kinds of autoloads will happen. Or maybe it's just soft fail it, just log an exception, but dispatch to the original. It's really interesting. It's really interesting measurement. So sometimes, like 3 weeks into production, there is a super arcane library being loaded. For the worst possible example was mass_n, which was loaded 2 weeks later, and mass_n overrides the division operator, and it's a really bad idea when you have lots of code in one library which depends on integer division semantics, and then suddenly you get a rational back. So I really recommend to at least maybe soft fail late requires. So just let them continue, you not cause a production error, but at least your team should be aware there are really bad libraries in the Ruby standard library. Recently mass_n has gone away, which is really great, but there are other counterexamples. So please at least try, if you take nothing out of this discussion where I just blame everything on autoloads, but please at least try to log late requires which you never explicitly intended or even knew about, so you can review them to not retroactively alter core classes. And it's really helpful, especially to get rid of stuff like third-party libraries, which in some specific input may require mass_n, and then fucks up your division operators somewhere else. Because there is so much network, there, especially in network chunking code, it's very likely that the integer division operator is used for integer division, and when it suddenly returns a rational, it would just, some web sockets go into a bad state. I've seen all this. So please, at least consider, should probably just eat my own dog food and release a library which you can allow to monkey trap these. And so it's a really helpful strategy to at least get something out of this panel.
Can you add trace point? Can you use trace point too?
Potentially you can use trace point. Let me just think about it. It has a code loaded callback, but the problem is that there are too many other ways which are not. I would have to review the API, and to my experience, tracepoint is not super stable, so I wouldn't trust it in production. So so I wrote a little bit of a spike in Mutant to get some trace-based selection going, and I found lots of edge cases where tracepoint really violated its own documented semantics, and I wouldn't recommend to try it in production.
Okay.
So I think it's more cheap to just overload the known sources of new code and just log an exception to your error tracker. No, it happened 3 weeks into running the production system that mass_n gets required, and you can get rid of it.
Can you imagine a tool that turns a Rails application into a more predictable Rails application?
Yes, I think what would be possible is that you just you could just record, you could just try to write a module which hooks all ways of new code is being loaded. You could hook that up into production, and you get a zip file out of it with just a single stream of Ruby code, which would reproduce the exact same semantics, assuming no request-based global overrides exist. But
the next question is, like, assuming that the Rails core team would be happy about it, would it make sense to introduce it to Rails itself?
To my experience, the Rails core team doesn't react really well to the kinds of thoughts I have.
Agree.
So it's.
I suppose they would like to keep Rails friendly for newbies.
So in my opinion, it should be a dedicated feature, not core feature you can explicitly require and drop later. That would be my ideal world. So to improve Rails, so it should just be so. Here is Rails, Rommel Rails we use for the block, we use for everything else, and here's Rails for the block example with all the hooks, which just makes the example more beautiful. That would lead to a better state for everybody. Because then you can just remove this gem, drop it, and just fix everything which blows up till you can run production again. Yes, but I thought I didn't track it closely, so they are really dropping it from implicitly shipping. So you have to explicitly. It's going to be in there. Do you have to explicitly deactivate or explicitly? Do you have to explicitly opt into using it? Yeah, then it's still shipped externally, but if it's active by default, it will be used by default and have its effect by default.
Yeah, but there's one.
What I'm saying is I think it might be easier
Okay.
to replace it because it's
Yes, so I have this 500-line monkey patch which removes any kind of Rails-based auto trigger loading. I would be so happy to just hook this specific one API. Obviously, yes, but it wouldn't be not as beautiful as I want it to be. Just comment out a gem from the gem file, but it's a really good point. If it's all going through one library, it's easier to get rid of it. Yes, but I'm still concerned about third-party libraries doing the native mechanisms.
There's one more thing, because that site work is going to use kernel autoload. And in that issue on Ruby issue tracker, there's a comment that probably they will change the behavior of the kernel autoload. So there's a switch which changes the behavior, whether you want that autoload statements to be eager loaded or not.
Interesting.
So,
yeah, but you can still simulate autoloading via a late eval. So it's not like you are not in Ruby. You're not dependent at all on the native autoloading feature, which gets wrapped into Sidework, which gets wrapped into Rails. So in my opinion, you need to have a global switch from which on all metaprogramming is gone, because only then you could still have a third-party library, but I want my late initialized mass and it require is gone, so I just eval the code into the. So all of this needs to go away at a certain point to have for your test environment to have any prediction powers over your production environment. Yeah, sorry. Okay, so okay.
Last question.
Okay, thank you.
Thank you.
Thank you.
Thank you, everyone.